Imagine taking a powerful, general-purpose AI, one that knows a little about everything, and turning it into a specialist, one that writes in your exact brand voice, speaks your industry's language, and nails a task it used to fumble, not by instructing it every single time, but by permanently rewiring it. That's fine-tuning, how a generic model becomes yours. It's also the most misunderstood and most overused technique in all of AI. So today, we fix that. Two things before we dive in. First, a promise. This episode is about the concepts, the mental model that makes everything else click. A full hands-on series where we actually fine-tune a model step by step is coming. So, concepts now, keyboard later. Second, a truth most channels won't tell you. Watching this once will teach you almost nothing. Real understanding isn't built in a single viewing. It's built by returning. Rewatch this. Pause it. Take notes by hand. Read a blog and a chapter on the side, and revisit it next week. The people who master this aren't smarter than you. They just come back until it sticks. So treat this as lesson one, not a one-time watch. Deal? Let's go. Here's our path. Where fine-tuning fits among the tools you already know, what it actually is, the difference between pre-training and fine-tuning, why and when you do it, the all-important role of data, the two methods, full and LoRA, the special tunings that built ChatGPT, the decision framework, the failure modes, and interview questions. Quick grounding first. Across this series, we've met two ways to shape an AI's output without touching the model itself. Prompting, just asking well, and RAG, feeding it external knowledge the moment it answers. Fine-tuning is the third and the most fundamental of all. Instead of changing what you give the model, you change the model itself. So here's the definition to hold on to. Fine-tuning means taking a model that's already been trained on a huge slice of the internet and training it a little further on a small, focused set of your own examples. So it permanently absorbs a new style, format, or skill. You're not starting from scratch. You're nudging an expert in a direction. Picture sending a brilliant generalist to a short, intense apprenticeship in your craft. To really get it, separate two stages. Pre-training is the giant, expensive phase. A lab feeds the model trillions of words, and it learns language, reasoning, and world knowledge. That costs millions, and you will never do it. Fine-tuning is the affordable second stage. You take that finished base model and adapt it on maybe a few hundred or a few thousand examples. Pre-training builds the brain. Fine-tuning sends that brain to school for your subject. Why bother when you could just prompt? Four real reasons. To lock in a consistent tone or brand voice the model holds every single time. To teach a specialized format or domain language it keeps getting wrong. To make it reliable on one narrow, repeated task. And to shrink your prompts, once a behavior is baked in, you stop pasting long examples on every call. Fine-tuning trades upfront effort for cheaper, steadier results later. But here's the trap that catches almost everyone. Fine-tuning is not how you give a model fresh facts. If you need it to know your latest prices or today's policy, that's RAG's job. Retrieval from last episode. Fine-tuning changes behavior. RAG supplies knowledge. Try to cram facts in through fine-tuning, and you'll get an expensive model that still hallucinates. Behavior, not facts. Underline that one. So what does fine-tuning actually involve? 5 steps. Collect a dataset of example input and output pairs. Format them the way the model expects. Pick a method. We'll see two. Train, which adjusts the model's internal weights. Then evaluate on examples it has never seen to confirm it truly learned and didn't just memorize. Collect, format, train, evaluate, deploy. Easy to say. And step 1 is where most projects quietly live or die, because fine-tuning is only ever as good as its data. This is the most important idea in the whole video. A few hundred excellent, consistent examples will beat 10,000 sloppy ones every time. The model imitates exactly what you show it, including your mistakes, inconsistent labels, typos, contradictions. It learns them all faithfully. Garbage in, garbage out isn't a cliche here. It's the entire game. Most fine-tuning failed stories are really my data was bad stories. Now, the two ways to do it. The first is full fine-tuning. You update every weight in the model. It's the most powerful and flexible, but it's expensive. It demands serious GPU memory. It spits out a full-size copy of the entire model, and it risks something called catastrophic forgetting, where teaching a new skill makes the model lose old ones. For most people, full fine-tuning is overkill, which is exactly why the world moved to this parameter-efficient fine-tuning and its star, LoRA, low-rank adaptation. The idea is beautifully simple. Freeze the entire original model, untouched. Then train only a tiny pair of add-on matrices, the adapter, that sit alongside it. You're adjusting a fraction of 1% of the parameters. The result trains fast, costs little, produces a tiny file you can swap in and out, and leaves the base model's general abilities fully intact. This is how fine-tuning became accessible to ordinary people. And it goes further. QLoRA compresses, quantizes the frozen base model so it uses far less memory, then applies LoRA on top, letting you fine-tune a genuinely large model on a single consumer GPU. There are cousins, prefix tuning, adapters, but LoRA and QLoRA are the names you'll actually use. The whole trend in one line: do more by training less. Two special kinds of fine-tuning, by the way, built the assistants you use every day. Instruction tuning takes a raw base model, which only predicts the next word, and fine-tunes it on instruction and response pairs so it learns to actually follow commands. Then RLHF, reinforcement learning from human feedback, and its simpler cousin DPO, fine-tune the model against human preferences so it becomes helpful, honest, and safe. Every chat model you love is a base model that was put through these fine-tuning stages. So, when do you use which tool? Here's the framework that ties this entire series together. Prompting. Your default, instant, free, no training, always try it first. RAG. When the answer depends on knowledge the model doesn't have, facts, documents, fresh data. Fine-tuning. When you need a consistent behavior, style, or format that prompting just can't hold reliably. And they stack. A serious system often uses all three together. Now the failure modes, because this is where money gets burned. Failure 1, and yes, I'm repeating it on purpose. Never fine-tune to add facts. Wrong tool entirely. Reach for RAG. Failure 2, overfitting and catastrophic forgetting. Fine-tune on too little data or for too long, and the model memorizes your examples instead of learning the underlying pattern. It parrots the training set and falls apart on anything new. Push too hard, and it forgets abilities it used to have. More training is not more better. Failure 3, cost and iteration speed. Fine-tuning takes data preparation, compute, and time, and every little tweak means retraining from scratch. A prompt you change in seconds. So the golden rule of this whole series: exhaust prompting, then RAG, then consider fine-tuning. It's usually the last resort, yet beginners reach for it first because it sounds the most impressive. So here's the green light. Fine-tune when you've already maxed out prompting and RAG. You need a consistent style, tone, or output format every single time. The task is narrow and repeats at scale, and you have a clean, high-quality dataset to teach from. Tick those boxes, and fine-tuning earns its cost. Miss them, and you're paying dearly for what a good prompt would have done for free. Interview round. What is fine-tuning? Further training a pre-trained model on your own data to adapt its behavior. Fine-tuning versus RAG. Fine-tuning changes behavior in the weights. RAG supplies knowledge at inference. What is LoRA? Parameter-efficient fine-tuning that freezes the base model and trains tiny adapter matrices. Biggest risk? Bad data, plus overfitting and catastrophic forgetting. And when should you not fine-tune? For fresh facts, with poor or tiny data, or before you've even tried prompting in RAG. Let's bring it home. Fine-tuning adapts a pre-trained model through its weights to make a new behavior permanent. Powerful, but data-hungry and the wrong tool for facts. Prompt first, RAG next, fine-tune last. And now, remember the promise from the start. Watching this once changes nothing. Come back to it. Take notes by hand. Read a blog and a chapter around it. Recap it next week and the week after. That repetition is the entire difference between someone who watched a fine-tuning video and someone who genuinely understands it. And that second person is far rarer and far more valuable than you think. The hands-on series, where we build this for real, is coming. Until then, revisit, imprint, repeat. If this helped, subscribe to @Techfluencer Eval, one AI skill every week. I'll see you in the next one.